Welcome now to video 7 in our networking series, and we're still on topologies. In video 6 we talked about the 6 types of topologies. Each one of those topologies has some characteristics that come up quite frequently when we're thinking about those topologies. So I want to discuss those now. And the first one, in the bus topology, we have a problem which we call collisions, and that's when two devices want to talk at the same time. You see, when any device, any given device starts talking, that signal, say this one in the middle, starts talking, that signal goes out here and down to that one, it goes up here, it goes to every other device. There's nothing controlling the direction that these signals go. So every device hears every communication from every other computer. Well, if two of them try to talk at the same time, then this wire just gets full. We have a collision going on. And so when that happens, we have to use some protocols to back off, wait for a period of time, and then have a systematic way for them to start talking again in order to get around this collision problem, which slows communications down, especially if this is a large network. With the star topology, we may still have collisions. Hubs, if we're using a hub here, and in this case I'm using a hub, hubs send transmissions to all devices. So if this computer starts talking and it goes across this hub, every other computer gets that signal, not just the one that is intended. But if I've got a signal coming back the other way, this guy's talking at the same time, signal's coming back, boom, you've got a collision. We have the same problem we had with a bus topology. So that's only if we use a hub for the central device. If we're using a switch for the central device, we have a solution to that problem. With a switch, only the destination, the intended destination, hears that signal. So if this guy down here is talking to this guy up here, that signal travels up here, straight across into this guy. Meanwhile, this guy is talking to this guy all at the same time. No collisions, because this switch separates all of these signals, and it only sends the signal out to the device that is intended to be hearing that signal at a given time. So we don't have any collisions here. And so that's why we use a switch rather than a hub, because it eliminates collisions. We would say that each of these computers is on its own collision domain. Whereas with the hub, we would say that all of the computers are on one collision domain. So with a hub, we still have a physical star. Physically connected, it's a star. However, logically, that is, when we say physical and logical, what we mean here is physically is how it's actually connected, the layout of the connections, how the wires are laid out. Logical means how the data moves through those wires. So logically, a hub creates like a bus. Remember, the bus also gave us a problem with collisions because all the wires are tied together. Well, a hub is like that. All the wires are sort of tied together, and so we have a logical bus but a physical star. With a switch, we have a physical star and a logical star. So remember, logical and physical, in other words, the physical layout and the way the communication actually travels through that layout might be different. So we call that a physical and a logical layout. Hub, physical star, logical bus. In the ring, note one little problem, and that is that every computer here must have two NICs, or network interface connections, or network interface cards is what NIC actually stands for. So, for example, your laptop may only have one Ethernet port in it. Well, it would need two of them in order to be able to hook into a star. And so that is a problem with some ring topologies. Another problem is that rings also create collisions. When something sends it out, it just goes around this ring in both directions, and pretty soon you've got collisions going on. And so that is a problem with ring topologies. However, so we have two problems here, the connections and the collisions. However, we have a way around that collision problem, and that is by something we call a token ring. What we do is we take a token, and this is just a digital token. It's not a physical device, but a digital token that we pass around, you know, like whoever's got the thimble can talk, right? You've seen that maybe somewhere in a therapy group or something. Whoever's got the thimble can talk. So as this token passes around from computer to computer, that computer is able to communicate. It only goes one direction, follows the token around. We have no more collisions. So a token ring does avoid those collisions. The full mesh has its own problems. It's costly, it's large, it's unruly. You notice that each of these PCs here would have to have a connection for every other PC, and this is only a small one. If we had a very large full mesh network here, we might have to have dozens and dozens of connectors on each PC, dozens and dozens of ports on each PC in order to be able to connect to everybody else. In fact, you need n minus 1. So, in other words, n being the number of computers, I've got 1, 2, 3, 4, 5 computers here, and look, each computer has 1, 2, 3, 4 connections. So n minus 1. 5 minus 1 is 4. Now we do get this multiple redundancy. I can go in all sorts of different directions to get to the PC I want, but it's a nightmare to set up, and it's costly, and I have to have all these connectors, which is not realistic. The partial mesh gets us around that. It reduces cost, and it still provides redundancy. So a partial mesh is really sort of how we get around the problem of the full mesh of all those connections to each computer. Finally, the hybrid. The only real note I can make about this is that the hybrid is the more realistic picture of what the internet might look like. I'll have stars, stars upon stars, maybe individual PCs. I can have rings and meshes and all sorts of combinations. This is a bus here, all sorts of combinations, and that's more realistic of what the world looks like. We have lots of different kinds of networks all connected to each other. So that's it for hybrid topology characteristics. And again, thanks for watching. And so this will be the end of the topology set in the networking series.